Hi everyone, I am Ronal Nargunde here to present on my topic Trendometer. Uh, During this project, I've tried to understand NoSQL databases and built a very lean application on the top of the NoSQL database that I have considered, which is Google BigQuery. So I have a small set of slides to help me explain what the project exactly is. Here is my first architecture diagram. So mm, a client application. I have built a client and trendometer application which sits inside the browser, and it is basically a visualization project. So Google Motion charts are used to display the results in form of charts. We'll see that in the demo. So what actually happens is when the user is given a chance to select the month in particular in any year, and make a request to the server. The application is supposed to be hosted on Google App Engine, but currently I'm going to show you the demo on localhost, so just that implementation is done. Uh, Deploying it on Google App Engine has some problems, and I'm going to look into it after this project presentation and the demo. The server um, basically going to go and talk to the a stored database and get the results and do some number crunching and I have put an algorithm to find out the trending developers for the given period and show it back on the browser. So what happens on this side is interesting actually. So this store database is pulling the results from Google BigQuery using its APIs. Google BigQuery is a NoSQL database. This is the first time I was working with it and understanding basically how and what about the Google BigQuery. Uh, so it has a project called GitHub Archive Timeline, which stores historic data from 2012. I think it's April 2012 till today. So that's a huge amount of data. It has everything about anyone on GitHub, whatever his activities are, whatever repositories he has created, blah blah blah. So much of information. So this database is trying to get uh, the information from Google BigQuery once. So I have made a request to the big data and copied 50,000 results in my database for this demo, and this database is hit every time the query is made. Um, and we'll see why this Google data store is used in a minute. And uh, this has to be maintained manually. You have to go and actually manually get data from here, and it's saved in tables right here, so that's not automated as of yet. um, let's go to the next slide. So the idea of this project was to research around NoSQL database. So this is a very complex diagram. Obviously, we have not used all of these technologies, but this will kind of help to explain what we are trying to do. So here is the Google BigQuery, and it has a lot of data stored in it. And here we have used the visualization tool. So ours is a Google Motion chart, which is supported by Google BigQuery. So the results are stored in a temporary database. That's our database right here, and the visualization is used and shown here on in the browser. So that's the idea of our project. So what we tried to learn during this project are basically the design strategies, data modeling in NoSQL, and uh, so many other stuff about NoSQL databases. I'm not going to go into the details of what exactly I'm meaning by these denormalization and aggregation and joins. So the idea is basically to model such huge amount of data. So what is the best possible way to do that is explained in the reference right here. Uh, these are the points from this same reference link that I have mentioned below. If you are interested, you can go there and really get into the details. It's pretty interesting. It gave us good insights of how the quantity of data can affect your your way of storing the data, or your way of querying the data, or how joins can affect how joins are very costly to do on this amount of data, or aggregation. If you want to really process so much quantity of data, you might need to do batch processing, and what are the ideas of batch processing, and so on and so forth. Mm, Next, we also learned about the design practices. So, firstly, when you start about this, you need to read the quota policies. So, I created my project, which is a DBMS project. So you can see it right here, and it gets a project ID and a project number. It's under my account. You need to put credit card details in case you hit Google BigQuery or their database. The more number of times you are charged some amount. So right here you can see that the request that I have made during my project. So as I said, I'm storing the some number of results from the GitHub timeline project into my local repository. So I have hit the uh, Google timeline project on these days and copied my results. So it has some quota policies wherein you can only uh, query so many number of times, so you need to go and read about it. So this is a Google BigQuery console, and you can see the GitHub archive project right here on the left hand corner, and this is my table which has 50,000 entries, and I'm storing these entries here, and this table is hit each time my project will run from the GUI. Uh, so also during the design practices, we studied about denormalizing data before loading it. This was not uh, applicable for our project because we are actually using the already loaded data, but we studied about it, and what kind of data is easier to access. Is it JSON or CVS? What are the implications of loading JSON or CVS? So Google BigQuery allows you to load CVS or JSON data. So that's what the pros and cons are discussed here. And the table partitioning, so how frequently your data is going to change, and that's what you need to consider, and uh, what is the cost for um, table partitioning. So we studied about it, and more in join of what happens when you're actually joining data, what you need to design your application and your tables in such a way that less number of joins need to be performed, and avoiding highly skewed data is discussed in detail. Here is a reference link in case you're interested. You can go in details right here. um, I'm going to quickly take you all through the demo of my application. So this is my application, and I'm selecting, let's say, January 2013, and I'll submit this query. So if you go to the Google BigQuery console, you will see a job is submitted, and the data is crunched. and you get it right here. And when I ask him to load the results, Google Motion charts will be loaded. It takes some time to load because it is heavy data, and so there you are. So on the x-axis you have days, that's in January, and here y-axis represents repository watches. So currently it's a basic algorithm. The more number of watches, the repository is trending. If I play from here, I can see the details. I can hover over the bubbles. Um, Also, I can check the languages that I'm interested in, and uh, read get to know about what's happening to PHP during this month. Or I also have this line graph. So this is showing PHP. If I just remove it, it has everything. I can go to the peaks and see what. So it's JavaScript and what's happening. Similarly, I also have a bar graph. Let me go and select days. So this shows the bar graph. You can play and see what's happening. If you select something, it will show you what's the status of those languages during that time. So the number of repository watchers for those languages are seen. Um so after this project, after the project demo, I just want to show you that here uh, on the Google BigQuery console, uh, under the project name that I created, you can see the recent queries that were fired. So uh, as I said, this is the table that is fired, that is queried every time the GUI wants some information. So you can see the time right here, and um, the algorithm that needs to find the trending repositories is inside the project. And Also, I would like to talk about the Google Data Store that we were discussing in the slide. So what's happening is that when you are querying this database, this data is stored is queried from the Google BigQuery, and the results are stored in Google Data Store under your credentials. So currently they are stored on the Google Data Store under my username, for my Google username. And so uh, if anybody else is running this project simultaneously, so if I host this project on Google App Engine, and two people simultaneously ask for trending developers, say person one asks for January and person two wants December, so the data that is crunched is not overlapped. That is, both of them will get correct results because the result is uh, stored under their own username. So this change for the username needs to be done in the project currently, but I'm working on it and things will change soon, and then I'll deploy it. That's the main reason why I'm waiting to deploy. After the demo of the project, I quickly want to explain my findings in the research of BigQuery. BigQuery is, even though we refer to it as a NoSQL database, but it is not really a database system because it does not have any indexes. You cannot mutate the data inside any row or column. You can just access it. So no updates and deletes are allowed. It has a very limited join capability. Uh, Basically because it is very costly. If you want to join two tables with millions of records, it's really almost impossible. Not really impossible, but yeah, difficult, costly. Tables do not have any explicit relationship between them. Uh, Basically, even in my project, which is the Trendometer project, the tables, there are no tables as such, but they are called data sets, and they cannot be connected to each other with any kind of keys, foreign key, primary key, this kind of structure. So what BigQuery is, it is basically an online analytical processing system, which we can just query and analyze the data, and we cannot perform any modifications. Let's quickly go over the pros and cons of the system. It is very simple. As you know, it has a SQL like query language, which is on, and it is all set up on Google infrastructure, so you don't need to maintain the database yourself. Mm, Also, it's very speedy, it's scalable, you can access millions of records in very less amount of time. It's secure because the access is on an SSL protocol. Also, there are multiple access methods, meaning that currently, as the Trendometer is a web application, I'm accessing this database via REST APIs, but there is also a command line tool available, uh, and there are many other ways you can access Google BigQuery. So this means that you do not require any special kind of expertise to access, um, no special language to access the database. Uh, Also, it does not have any complex schema design. Uh, so design means that you are tuning your strategies so that you improve your performance. But here there is no such thing. They're just blobs of data you're going to hit and get the results and perform your algorithm to mm, check about trending repositories or developers or whatever is the scenario. Joins can mean restructuring tables, which means that if you at a later stage of your project, if you feel you want to join two tables, you want to take some more data and consider it also along with your current tables under consideration, it would mean that you cannot have two separate tables. You need to just drop the two tables and create one single table. So it means restructuring of your tables. Also, there is no access control uh, to these data sets. Either everybody can see it or everybody cannot see it. There is no other way you can make create views out of it, views which are an SQL concept that we know. There is no such kind of thing in Google BigQuery. Thank you.